Yeah, hi Karthik.
Hi, Santosh.
Yeah, so let's start today's session. So in the yesterday session, we have completed the theoretical part of logistic regression, right? So
Yeah.
so these are the like full concepts what we have studied. Started with the basic perception trick, WIXI part, and then we have seen the issue what we are facing, correct? And then we
Hmm.
brought in the sigmoid function, and the advantage of sigmoid function is it is ranging between 0 and 1, right? And then mainly we understood the probability whatever that is giving by the sigmoid function will be for the positive class one. So from that, how we can derive the negative class probability. And then a simple math, we understood three four things like what is maximum likelihood, and then what is cross entropy. So final thing what we want is a cross entropy. Okay,
Yeah. Yes.
so this cross entropy is nothing but the summation of the negative
Summation of negative loss
maximum.
of maximum likelihood.
Okay. Yeah, so this is all simple max, right? But the main concept is using the sigmoid function and getting the probability, and then using that to do the classification with a threshold of 0.5.
Hmm.
Okay, fine. So today we'll see the practical code. Okay, as I said, code will be always be simple for machine learning algorithms. Okay, but before that, yesterday at the end of the session, we were asking, right? So like, will this happen? Like all the process what we have studied. I mean, these are the steps, right? So
Hmm. True.
that will be okay followed to get the line, okay, the
True.
best line which separates. So you're asking like, will this happen for all the points, right? So yeah, so
Hmm.
yesterday I said that yes, it will happen for all the points. That is true, but the main point here is, if you want how it will happen, like will it happen for only one point or only batch of points? It depends on the gradient
Hmm.
descent. Okay, in
Okay.
the gradient descent we have studied, right, different types of gradient descent. So what is that?
True.
If you remember, mainly we studied about three types of gradient descent. Okay, types of gradient descent. If you see, uh, three types, right? So one is a batch gradient, one is stochastic, and one is the mini batch. Okay, batch,
True.
batch, stochastic. So one fundamental difference is what in batch you will send the complete data set. In mini batch
Hmm.
you will divide it into
Different batches.
small batches. In stochastic it will take only one data point
Hmm.
randomly, and then it will start doing the gradient descent operation, right?
True.
So here also same thing will happen. So here also,
Okay.
if you use the
Hmm.
batch gradient descent, right?
Okay.
It will calculate the loss for the whole batch. That means it will pass the complete. It will pass all the 800 data points. Okay.
Okay.
At the end, it will calculate the loss and it will do the derivation and replace those values. And with respect to all those 800 points, whatever the value you are getting over here, based upon that, a new value of W will be calculated. Okay,
Okay.
so WN will be based upon all 800 points. Okay,
Okay.
used for batch.
Hmm.
So that is the
Yes.
importance of gradient descent. Now you will be understanding, right?
Yes. 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 Got it. Yes.
But if you go for mini batch, let's say you have divided this into four batches, like 800 by 4. Okay,
Hmm. 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 Four
so it will
batches. Yeah.
just 200 points and do this calculation,
Process.
pass
Hmm.
those 200, get the loss, and for every 200 it will change it. Okay, so
Yeah.
that means
Hmm.
what, four times it will change, right? So
True.
for mini batch you will
True.
have
True.
four mini batches. So for
Yeah.
every end of the first batch 200 data set points, it will you will have a new WN, right?
Yeah.
So coming to stochastic, so randomly it from the data set it will take for each data point, it will check and randomly it will change it.
Yeah.
Okay. So how it will change, how many times it will change, it depends upon the your gradient descent selection. Okay. But
Okay.
we during this class, I told you that stochastic works very well because
Yeah. Yeah.
it
True.
takes only one data point and randomly it tries to find out that baseline, and most of the time this will be successful. Okay.
Okay.
So this is how it happens.
Hmm.
Okay. Is it clear now?
Yeah. Yeah.
Okay, fine. So now this is how you are going to get the line. Okay, and that line will be obviously W1 x1 plus W2 x2 like that, WN xn. Okay,
Hmm.
all these W's. Okay, all these W's are what are the coefficients of the line.
Hmm.
Correct. And each one
Hmm.
coefficient is related to its corresponding feature. All these x are what? X are features,
Features.
input features.
Features.
Okay. So for each feature, you'll have one coefficient.
Hmm.
Okay. So if you think about it, so it is interesting. So what if you get a line? Okay, for example, you get a line of 10x1 plus,
Mm-hmm.
for example, 0.5x2. Okay, and let's say some 7x3, three-dimensional data. Now,
Mm-hmm.
what does this coefficient saying, you see? So after completing all this, you got finally this is a line. So that means
Mm-hmm.
what? So if you see normally, what are the features? So x1, x2, x3. That means what?
Mm-hmm.
Whatever the value you have in the data set, those are the features. Okay.
Mm.
The line is 10x1, 0.5x2, and 7x3. That means after calculating the complete loss function, whatever the thing what we are doing, whatever the logistic regression is deciding that x1 is more important, the
Mm.
feature, whatever the x1. So that's why give 10 times important. So 10x1. Correct? It
Okay.
is increasing
Mm-hmm.
the value of x1. So I'm saying how you should understand the meaning of that line. Right?
Okay. Got it.
X2 is not that important. So take only 0.5%. That means if x2 is the actual value is 20, take only 10.
Mm-hmm.
Okay. If x1 is 10, take it will become 100. Okay.
Mm.
And 7 is mediumly important. So if it is x3 is 3, it will become 21.
Mm-hmm.
So that's how, like, it is indirectly saying. So finally the line is saying it is basically going through all the input data and saying how much important each feature is. Okay. How much I need to amplify each feature.
Got it. Got it.
And
Got
how
it.
much I need to decrease that. With
Got
that,
it.
it is going to give you one line.
Okay.
Okay. So that
So
line will be the basic.
in this, yeah, in this case, we can consider like the take Titanic. So 10x x1, if we take like a class,
Yeah.
I mean
One will be
class
some,
one,
yeah,
class
so X1, whatever the feature you get, yeah, P class.
five,
Okay.
P class, like
P class.
okay.
So it is saying, so that much importance I'm giving
Okay,
to
got it.
X.
Got it. Got it.
Okay, fine. So now let's see some code logistic regression. So as I said, it will be very simple. For example, if you see, yeah. So the basic thing is you're going to import the data sets. Okay. Hard data I am importing. Okay. So
Mhm.
what do we have? So we have the basic is a classification problem, right? So that means whether that person will get a heart attack or not. Okay. So the target value is 0 or 1. Okay. 0 or 1. 0 means he will not get an heart attack. 1 means yes, he will get a heart attack. Okay.
Okay.
So this you need to, so obviously first priority is you need to, okay, check whether we are doing classification problem. Yes. And after that, you are having the few features. Okay. All these are numerical features as of now. Okay. But
Okay.
in some cases, you might get some, okay, I would say categorical features. Okay.
Mm-hmm.
Like male, here, see, already we got the data
Text,
is
yeah.
one and two, but sometimes it will be male and female. Then you need to encode those into the.
Hmm.
So now we have these features H6, CP, stress, what is stress BPS? Oh, I'm not, we don't know. We are, since we are not
Yeah,
doctors,
yeah.
we don't know what are this, but from machine learning point of view, we consider these as features. Okay.
Yeah.
And this is the output target variable. Okay.
Hmm.
Fine. So now, uh, sorry, yeah. So now, what we are doing, so we are trying to divide this into training data and test data, right?
Yeah.
So you know, right? Overall
Yes.
data divided into training, testing
Yeah.
data, okay? And then we build the data based upon training data, correct?
Yes.
And then we use the test data, and from this you will get the predictions, okay?
True.
So yeah, basically this will be, here you will have X train, Y train, okay? The
Hmm.
same thing. So on the training data, you will train the data model. Finally, when you get the model from the test data, you only pass X. Okay, sorry, you will get pass X. Model will give you predictions. Okay, so you
Then we
are
need to compare with the test Y and yeah, predictor.
based upon these two, you will calculate the accuracy, whatever you want. Correct.
Yeah.
So the
Hmm.
same thing here. Okay. So what you are doing? So you are importing the train test split train from sklearn dot model selection. Okay. So the train test split, how you are doing? See, this is X. Okay,
Yeah.
and this is Y.
Yes.
Fine. So how? Because if you see, DF is my data frame. Okay. So in DF dot iloc, I is what? I is take by index. Okay.
Yeah.
So this is 0th index, 1 index,
Yes.
2 index, like that. Okay.
Okay.
In that, take, see, here you are saying just is 2. You're not mentioning anything. That means
Yes.
what? See, you have a
Complete.
comma over here. That means this is rows, this is columns. Okay.
Yes.
So these
Yes.
two means you're not specifying anything. So that means take all
Com-
rows.
All
Okay,
those.
take all rows. But
Yes.
what columns? From 0 to -1. So see, this
Here
is
-1, -2. Yeah.
it will be
Come back.
-1. Okay. So in Python, the index will be always from end index -1. That means if
True.
you say 0 to 5, it will take 0 to 4. 0 to 5 means 0 to 4. End index
Yes.
-1. You remember, right?
-1. Yes.
So
Yes.
here also I'm saying take from 0 to -1. So
Hmm.
-1, -1.
Yes.
Correct? 5 -1, 4. Here also I'm saying take till -1. So I'll do -1,
Yeah.
-1, it will be -2. That means
-2.
-2.
THA. Yeah.
Okay. So from age to this tal. Okay.
Yes.
This will be my X.
Yes.
Clear this part. And
Hmm.
now here for the Y, I'm just saying df.ilog. So take all rows. I am not just specifying -1. Okay. Just take the
Hmm.
-1 column. So this is obviously only the -1
Target.
column. Take
Yes.
this.
Yes.
Okay. So now this became X, this became Y. Clear?
True. Yeah.
Fine. So after that test size equals 0.2, you know this, that means out of overall data. So
Yeah, we have
do
0.2% we are
80%
taking.
to train, remaining 0.2 means 20% to test.
Right.
Okay, this random state I already
Hmm.
discussed it. Okay, fine.
Yes.
So now my data is ready. Okay, so my overall this data is divided into four parts: X train, X test, Y train, Y test. Now the main thing is how we are going to import the logistic regression model. Very simple, just like how we did the linear
Yes.
regression. So we are going to do it in the same way. Okay, so because for example, when you say from sklearn dot linear model, okay, import. See, when I do after import, when I just do tab, so it will
Yeah.
all the modules that are available in this library. Okay, so all these are belonging to linear models. Okay, so in that earlier we saw linear regression, so now it is logistic regression. Okay, so like that you will just import it. So that means what? So I told you, right? So in Python everything is an object, right? So that means everything is an object. That means this will belong to some class and object. Oops concept, simple. Correct. So everything is an object, so that means even this is also an object. Correct.
Yes.
So that means it will belong to some class. So what we're doing here is, see, logistic regression is what we're doing from this library, this module. I'm just importing this class.
Yes.
Okay? From this library, from this module, from I'm importing this class. Okay, so that's why logistic regression is class. In this I want to initiate one object. So when you do this, right,
Hmm.
while importing, just I'm doing this, but when I do this parenthesis, that means an object is created.
Okay.
Correct. So now CLF1, whatever name you give, but CLF1, now it is an object of logistic regression class.
True.
Okay, logistic regression class. That means whatever the code we studied yesterday, the max, sigmoid
True.
function,
True. True.
everything, right? So
That is
that is all that is
everything will be
present
assigned
here.
to CLF1. Yeah.
Correct? That is present here in the
Yes.
class. So when I initiated, okay, and created an object CLF1, so all that is now applicable to this one. So it can now
Yes.
access logistic regression features, it
Yes.
methods, attributes, etc.
Yes. Yes.
Correct? So this
Yes.
is how we just import the class and create an object.
Model.
So this is
Yeah.
a logistic regression. So now what we're doing simple. So we got the X train, Y train. You take this X train will and Y train. Okay,
Hmm.
and we fit is train is simple fit. Okay, CLF dot fit training is done. Okay, simple. See, last two classes done in just two lines. Okay,
True.
import, create an object, fit. So training is done. So when you say fit in this one line, all that thing happened. So as I said, right, so whatever we are studying, right, so it will just take this data. Okay, it will
Yeah.
take this data and it will do these steps. Okay,
Yes.
it will
Yes.
for each and every point it will calculate wxi. Okay, this and then pass it to sigmoid function, calculate the loss, etc., etc., etc. It will try to do this. Okay, and then the model is set, and
Hmm.
correspondingly you have the white train variable on.
Veteran.
Okay, why this white train variable is important? Because here you see in the loss function you
Predicted one.
have minus y.
Yeah. Actual one.
Yeah, actual. So here you need the actual y variable. So this is from the model or sigmoid. So for
Correct.
that, you need to pass the white train also. So this information we are giving, so model is fit, done. So
Yeah.
now, yeah, so it is saying logistic regression is created. So now after that, what we are saying, so you can use it for the predictions. Okay.
Yes.
So I'm saying clf.1.predict x test.
Mm-hmm.
Training is done, so I'm passing the x test. And now when you pass it, you are going to get the predictions. Fine.
Yeah.
So if you see the predictions, how it look like. Okay, so these are the predictions. That means what?
True.
If you see the x test, right? So these are the x tests for the first value.
Yeah.
Uh, the model is saying 0.
Yeah.
Okay, the model
Correct.
is saying 0. Fine.
Yes.
So, for example, if you see what is my actual data? Data is df. Okay, so if I say df dot ilog of 546, is this the same one?
Yes.
Okay, or if I do give this one, it will give in the data frame format. Okay, yeah. So
Mm-hmm.
from what I say from my see, this is after dividing the data set. X
Yes.
test X and all these are after dividing the data set.
Yes.
Okay, but my original data set is what df,
Yes.
correct? So, but indexes will be same. We did not reset the
True.
index. That
True.
means what?
True.
After dividing, if you reset the index, that means the index will again start from 0, 1, 2, 3.
Correct.
Okay, but we have divided the data set, but the indexes are same.
Yes.
So whatever the 546 you are having over here, the same record will be present in your df because everything
Yes.
is getting created from my df, right?
True. True.
Right. So over here now I'm just seeing. So this is my X test. Okay, this is just for testing. I did not send it during training purpose. Agree?
Mm.
Correct.
Yes.
So training is only training data. So after but testing I sent it. So but as you can see here, target data is missing. Correct. I
Mm-hmm.
did not send why. So but in the actual data set, this is a information we are having. Okay, but and it is target is 0. That means this person did not have heart attack. So but
Yeah.
what model is saying that
Mm.
we will get it from Vibrate.
Correct.
Okay. So for the vibrate, if you see for the first row, the value is 0. Okay.
Correct.
So that means model is also saying, yeah, he did not get return.
Correct.
Okay. Fine.
Yes.
So, or for example, let's say this, let's see 1, 2, 3, 4, 5, 6, or fifth one, right? 846 is the fifth one. So 1, 2, 3, 4, 5. This one. Okay. 1.
Mm.
So for the fifth one,
Mm.
this is 1. So what 846 is the index. So I'll just go here and say 846. So I got this one 35, 138, same 138, this one,
Yes.
correct? So for this guy, he got a heart attack. Okay, as per the
Yeah.
that is one. Okay, so but in the
Correct.
model is saying 0, oh sorry, 1, 2, 3, 4, 5. Okay, yeah, he got a heart attack. Model is saying. Okay, so
Mm.
some examples we have seen that means the model and our
True. True.
syncing. Okay, we
Correct.
don't know how many are syncing. So for that, we can check the accuracy. So okay, we can
Yeah.
come down and see. Yeah, the accuracy is for accuracy, what we'll pass? We'll pass the actual Y test and our predictions. These are our predictions.
Mm. Mm.
When you pass it, so it is saying 83%. Okay,
Yes.
83.9, almost 84, I can say. That means 84% of the time my model is predicting correct. Remaining
Correct.
16, it is failing because the reason could be why, if you think about it, the reason
Mm-hmm.
could be that data might not be perfectly separable. Okay, so
True.
only if you have the data completely like this to one side and remaining data to one side,
Correct. Correct.
if you get
Correct.
a
Then
line
only
like
we
this,
can.
you get 100% accuracy. Okay,
Yes.
but in real life, sometimes it is very difficult, right, to find because who will
Yes.
give you this type of data? So there will be some misclassifications here, this might come here, right? So in that
Yes.
case, you will have a line, but the best line. I'm not saying the perfect line, the best line which you can get. That means the line which is giving the least number of misclassifications.
Correct.
Agree? The same thing, even in the linear regression also, we did not have a line which will pass through all the data points, correct?
True.
So if
True.
there are data with the points like this, we never had a point which can pass through all, correct?
Correct.
There are some
Correct.
points which are missing from the line, but
Yes.
we are just getting that line which will have the least error. That means as much close as possible to all the data points. Similarly,
Yeah.
here also, you might not be able to divide 100%, okay, but
Mm.
the maximum whatever you can do. Okay,
True.
so if you ask then how we can improve this, for that you have another models, better models.
Yeah. Yeah.
Next
Yeah.
we are
Correct.
going to see, yeah, next for example you are going to see SVM, right?
Mm.
So that is a bit better model, and then you have later you call trees, okay, that even more better models. Okay, So, but since we studied logistic regression, so this is giving not a bad accuracy, decent accuracy you are going to get. Okay, fine.
Yes.
So I would say this is simple. See, building a model logistic regression is this much only.
Correct.
Okay, this is
Yes.
simple. The only thing that can vary, okay, is your EDA. As I said,
Hmm.
most of the time that will go is into data processing. Okay,
Yes.
data processing and EDA, exploratory data analysis, means what? For example, here you directly got the data, but sometimes
Hmm.
you will they will not give
Data.
you the age. For example, they will
Correct.
give you date of birth.
Correct.
Okay, you need
We
to
need
keep the
to
date from that.
form. Yes. We need to
Create a
extract
small
as well as
function,
we need
pass
to handle the missing
correct,
values.
missing values, correct. Okay, and sometimes you will have the categories like
Also, yeah, yeah, it's a not numeric data that we need to convert into numeric. Yeah, complete.
correct. Okay. And yeah, same thing. For example, FBS. Okay, he gives
Hmm.
0 and 1, but this might be actually, for example, let's say whether this person has used ventilator or not. I'm just guessing, but just
Hmm.
ventilator, yes or no, might be the case. From that, we are converting it into 0 and 1. Here also doing into binary. Okay. So like that, few pre-processing you need to do so that you will get the cleaned data. Once you have the
Yes.
clean data, then your road is clean. Okay. Then you can
Okay.
directly, all these are pretty straightforward, nothing
Yes.
different. Okay. So I think we have seen few examples on the EDA also, if I remember
True.
currently.
Yes. 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 Yes.
Okay.
I
But yeah,
remember.
yeah, if you have time, we will see few more in future.
Yes. Sure.
Okay. Fine. I would say that is one thing. Now, building logistic regression, okay, that is what we have seen, which is not difficult. But second thing is any model, right? So we have few hyperparameters, Karthik. Okay, that is
Okay.
important.
Okay.
Okay. So hyperparameters, that means what? There are few when you are starting a model, right? So here, when I showed you, yeah. So when I showed you that I am starting a linear regression model, so I just said logistic regression. You got the model, right?
Yes.
But for example, if you go and see the official documentation, okay. So as I say, always go follow the official documentation. So any model you will find it in the scikit-learn linear regression. Okay. For example, you can just type sklearn
Hmm.
scikit-learn logistic regression and just go to this one. So here it will tell you the complete usage and full detail
Yes.
of logistic regression. Okay. So
Yes.
he's saying the class is this one. Okay. The class is sklearn.linear regression. Sorry, linear model. Okay. And from that you are importing the logistic regression. Whatever you're seeing over here, right? These are the
Yes.
hyperparameters. So
Yes.
hyperparameters are what? So they are like just the knobs, switches. Okay. So for example, I'll give you a basic idea, then we will see those hyperparameters. These are very important because see, model is model. For example, linear regression or logistic regression. When you do this logistic regression model, you are getting not model,
Yeah.
it means untrained model.
Correct.
Okay. Training is not done. Okay. You are just, for example, let's call a logistic regression object we have created from its
Hmm.
class.
Yes.
Okay. Now, when I say instead of this, when I say this, it is also having all the hyperparameters. For example, if you see, you are having penalty, dual, total, C, etc., etc.
Correct.
All this
Correct.
you are having, right?
Correct.
But here I did not give anything.
True.
But still, all of those are present here with the
By
default values.
default value it
Okay.
will take.
For
Yes.
example, if you see every hyperparameter will have a default value. See here for the first
Correct.
penalty. So penalty,
Correct.
all these are values are there available.
But L2
If you
L2
don't
is
do
the
anything,
default.
it is L2.
Yeah.
Okay. Similarly, some other parameter, it's default value, default value. For everything, there will be some default value. That
True.
means
True.
if you are okay with the default value, just give like this. Okay.
Correct.
For example, no, I want penalty,
Should
uh,
be L1.
some other thing. Okay. For example,
Hmm.
default is L2. Okay.
Hmm.
I don't want L2. I'll go with L1. So if you want
Then we
L1,
need to mention.
specifically mention. If you don't give,
We need to mention. Yeah.
if
It
you
will
don't,
take date
it
L2.
is L2 automatically. It will not show
Yeah.
you, but by default, that's why you should refer to documentation. Here it is saying by default L2.
Yeah. Yeah.
Okay. So now
Hmm.
what is see? This is also logistic regression. This is
Correct.
also logistic regression. But you need to test and verify which is giving you the best result for your data set.
Okay.
Okay. Both are models only. For example, let's say, uh, yeah, see, let's say you have a car, I also have a car. For example, you have i10. Okay. I also have i10 car, Hyundai,
Hmm.
for example. But your car might have some extra fittings,
Mhm.
correct? So I might have, for example, say best music system.
Hmm.
Okay, you might switch to automatic, for example. Okay, I might have like best suspensions. But
Yeah.
if you see both are cars, both will serve
Correct.
the purpose. But your
Correct.
experience will differ, vary, right?
True.
Just like, but at the end of the day, both are models, same models.
Yeah.
I10, what is the model I10? For example, here Hyundai is a class. Okay, in that one particular model is I10. Correct. Here
Yes.
also, logistic regression is the actual. I mean, the linear model is the class. Okay, in that you are taking one object or model called as logistic regression.
Yes.
Agree? So you can build if you change these variables, right? So this, for example, uh, yeah. So if you for one model you can build with L using penalty equal to L1 and dual equal, let's say bool, and C equal to some value, and maybe this class weight equal to balance, etc. And some
True.
other model you can use completely different. So both will act differently.
True.
Okay. I'm not saying there will be much changes, but based upon your data set, the final line which it is giving, right? So that might be different. It will not be
Okay.
perfectly same.
Okay.
Just like you can
Got it.
refer to this example. Just even though
True.
both
True.
cars are exactly I10, but the experience will be different. Your mileage might
True.
be different. My mileage might be different.
True.
Correct? Everything
Yes.
will everything will vary.
Yeah.
Correct? Similarly, that's the reason. But which particular hyperparameter is the best if you want to know? So then there is no hard and fast rule. So you need to just experiment. And
Will
for that you
trial
have
and error.
called as no, not trial and error.
No.
We have techniques
Okay.
also. We have something called as grid search CV and random search CV. If you have,
Uh-huh.
did we study this? I don't
No. No.
know.
No.
Oh, okay. Then we'll see in future classes. I remember sometime I have given you basic idea, but I let me check once. Okay, but we have techniques. We will see
Mm-hmm.
where you can just pass in different random. I mean, you can just pass in whatever values you want to experiment. For example, I will say, hey, experiment with L1 and L2. Choose L1 and L2
Okay.
from this, and choose some values for here, and choose some values for here, and choose
Okay.
values of here. And from this
Okay.
solver, let's say I'll choose this one, and this one. Okay, and you'll get a you'll give these different categories, and let's say you
Mm-hmm.
have something called as grid search.
Okay.
So what it will do is it will search, it will take all different combinations.
Okay.
With each combination, it will create a model and test the accuracy.
Okay.
Now it will go to some
Okay.
other combination. Like penalty is something, solver is something, this is something, new model, new model. Like
Okay.
that, it will
Okay.
keep on trying. At the when I say new model, what does it mean? Say new line, right? You should visualize
Yes.
a line.
Yes.
So when I'm saying a
Yes.
model, so everything is
Line.
changing. The loss is
Correct.
changing, the probabilities are changing, a new line is you are getting. Okay. The same thing is happening. Okay. So there are few techniques. We'll see that. But the main point here is when you change the hyperparameters, obviously your model is changing
Model will
and
change.
accuracy
Yes.
is going to affect.
Yes.
Okay. So that's why to understand this hyperparameters is important.
Okay.
Okay. But luckily, most of the time, we don't change much of the hyperparameters. If you want to know, I mean, if you want to change, if you are very confident that what does each of this value mean, and if you think that your data set works well with some other hyperparameter, you can, or you can experiment. But most of the time, we don't specifically
We'll
give
go
any
with default
specific
one. Okay.
hyperparameters. We'll go with default. Okay. But it is always
Okay.
important to understand what these hyperparameters are. Okay. So we'll see if
Got
you
it.
want, but all of these are not important because no one remembers or understands what everything, for example, what is TOC, it's no verbose, etc. Warm start. All these are not important. Okay. This will be by default. But few important things are, for example, if you see the penalty. Okay.
Hmm.
So if you see this penalty, so what is L1? This is related to regularization. Okay. So you remember regularization techniques we studied in the
Yes. Yes.
linear
Yes.
regression,
Yes.
L1 and L2
Yes.
types of no, not JD regularization. Yeah, L1, L2. So
True.
this is called
Yeah.
L2,
Rigid.
L1.
Yes.
Okay, so I'll just quickly give you idea of what is regularization. So because we built a model, that is fine, but the problem is it can overfit the data.
Yes.
Okay,
Yes.
overfitting is a problem. That means the line
Yes.
is perfect. Okay, but sometimes it is overfitting. That's why you will add some additional term.
Yes.
Okay, so that it will not overfit.
Correct.
Okay,
And
so
also under fit.
yeah, so
Yeah.
this was our loss function. Okay, till here, if you consider only till this point, it is fine, but it is overfitting. But
Yes.
that's why what we are doing, we are adding an extra term. This is extra term for
Yeah.
L1. This is extra term for L2.
Correct.
Agree? So now, earlier when it is when you don't add any this part, you have only this much loss function. So
Now
the
it's a new loss function. Yeah.
yeah, correct. So the gradient descent will try to optimize only this. But now when you are adding this, it will be more difficult for it so that the chances of overfitting will reduce.
Yes.
Okay. So then we had a detailed discussion like what if lambda increases.
Correct.
So all these things we have seen, right? So and
Yeah.
one quick thing I was saying you right in L1 regularization. So it is also possibility that some of the features can go to zero also.
Hmm.
Correct. So we have three cases greater than zero
Yeah.
equal
Greater than 0, equal 0, less than 0. Yeah.
can go to zero. Okay. Just revise this one. The same concept. As I
Okay.
said, gradient descent concept is independent of any model. It is same for
Okay.
it is a separate concept. So you can apply it to linear regression, logistic regression. So there
Okay.
again, similarly, regularization is also an independent concept. So you have L1 and L2 regularization, and related to that only this one. Okay,
Okay.
so whether you want to use L2 or L1, lasso, reach, or elastic net, correct, etc. If you don't use anything, so by default it is saying it is going to use the L2 reach one.
Yeah.
But if you want L1, okay. But best thing is if you have time, okay, and if you have the resources, you can just experiment. Use
Okay.
this one, build a model, test accuracy. Use this one, build a model, test accuracy. Make an Excel sheet. Then you can compare. Okay. Then dual is not important. Okay, so this is also not much important. Okay, but C is the regularization parameter, Karthik. Okay, this is important. So that means what? C is inverse of regularization strength. Okay, that means what? C is inverse of 1 by R. R is what? R is regularization strength. That means if you increase the value of C, your regularization will decrease.
Yes.
Okay? That means what? What is the problem regularization is solving? If we have having good regularization, then there is no overfitting.
Yes.
Okay, then there is no overfitting. Okay,
Okay. Then C value will be less here. Yeah.
correct. But yeah, correct. Okay, so if your C value is increasing, then your regularization is decreasing. That means if
Yeah.
you are not using any regularization, again overfitting.
Overfit will be more.
Yeah.
Yeah.
Oh, sorry, this is overfitting. Yeah, this is overfitting, right? So then if C is more, R is less. R is less means regulation is less. That means overfitting will again come into picture.
Yes.
Okay? If you are overfitting means what? You are having training data, you are having test data, right? On
Yeah.
training
Yeah.
data, it is getting perfectly fit, but it will struggle on the test data
Yeah.
because it is overly fitting on the training data. So then it will not have error over here. That means bias will be low,
Yeah.
but it will make error on the test data. That means variance will be high. This is a problem. Clear?
Okay. Yes. Got it.
Yeah. But reverse is if you decrease the value of C, now regularization will increase. That means you are using good regularization. Okay. So that means what? Your overfitting chances will decrease. If overfitting
Yes.
is not happening, that means on training data also it is fitting well, not overfitting, just fitting. So that means error will be less. That means your bias will be, it will a bit more bias you can expect, but it will perform well on the test data set. On test data set, your variance will reduce. Okay,
Yeah.
your variance is more, but here the variance will reduce. Bias might slightly increase. Okay, but on test data set, it will work very well. Okay, so a increased bias with much reduced variance is what we'll say. Okay, for example, here I have seen here that point. If I can find it, I'll just show you. Where's the bias? Underfitting loss. Yeah, so bias will increase, okay, but variance will decrease.
Yeah.
Okay, so fine. So that is regarding this part. So you can test, okay, by default it will be one. So, but you can give different values and test, okay, which gives you the best accuracy. Fine.
Okay.
And after that, this is not important, and intercept scaling, this is also not important. You can read here. Frankly, I did not, change any of these values most of the time. Okay, the by default values worked. And a class weight, for example, if your classes are having imbalanced data set, that means, uh, I mean, if you're having 0 and 1, right?
Yes.
Now, heart attack, not heart attack, but out
Yes.
of 800 values, if only let's say 50 values are belonging to this one and remaining 750 are this is an imbalanced data set. correct? Because
Okay.
the model to get
Yes.
trained, it is not having enough information. Only 50 data are present over here. Okay,
Correct.
so this is an imbalanced. Okay, so in that case, to handle that situations, we have some parameter class weight. So it will multiply with weights concept. Okay, so you can
Yes.
do this. And random states, not important. And solver, yeah, solver is related to optimization technique. Okay, uh, so for it, the by default you will have these are different solvers. Okay, by default it will be LB, FGS optimization related to the gradient descent part. Okay, so which different solvers which can give you better line. Okay, so Newton Cholsky, I not okay. What is SAG, SAG? No, I did not. Use any of these. I would say because I basic was working fine. Okay, but if you want, there is also a table like which works well with this. If you are using this penalty, which solver will work, etc., etc.
Okay.
Okay, fine. Now, uh, the class. Yeah. Now, when you're seeing multi-class, right? So multi-class. Okay, fine. That thing I'll tell you. And coming to Webbos, Wormstart. Yeah. So njobs. Njobs is one hyperparameter which is common in any model. So that is nothing related to model, but it is related to your hardware. Like in your hardware, if you
Yeah,
want
yeah, number of CPU. Okay.
cores, if you want all the cores to be used parallelly, so then you can use the njobs equal to 1.
It depends upon data. Yeah.
Correct. Okay, fine. And etc. Fine. So now one thing is, yeah, that is regarding the hyperparameters, right? So, but one thing, Karthik, here we understood. Uh, yeah, but before that, did I miss? So we checked the code and we saw the hyperparameters. Yeah, coming to the assumptions. Okay, right. So now every model will have few assumptions. Okay, just like in linear regression also we had assumptions. Okay, the only one assumption I told you was that it will expect that the model will be uh, what is that? They'll have a linear relationship between them.
Yeah.
Correct? That means if one is increasing, other should also increase or decrease. Some linear relationship should be there. Correct? So, but not that is not the only linear regression assumption. There are also few. Okay, so I will take separate session on that. Okay. Uh, but coming to logistic regression, here we don't have many assumptions. Okay, one is the data, the target variable should be mainly
Yes.
binary.
Binary.
Okay, that means mostly it should be
Either 0 or 1.
pure one. But that is that is what we have designed the logistic regression. But it will also work for multi-class too.
Multi-class.
That means even if you have 0, 1, 2, 3 class also it will work. But here how it will work is just small creativity. So in this case, what we'll do is we'll consider 0 as one class and all this as one class.
Okay, got it.
Okay. So let's say this is some class 4. So now again the the game is between only 0 and 4, whether it is 0
Right.
class or 4 class.
Got it.
Okay. Now, once this is done, again in this we will divide it into 1, 2, 3. So 1 will be one class and 2, 3 will be another class.
Oh, okay.
Okay. So whether it is dividing or not. So you can, so it will be like 1 versus OVR. OVR
Okay.
stands for, uh, I forgot honestly, but somewhere here we have seen here, right? OVR out. It was something.
Yeah, there is it.
Yeah, we have here OVR, but OVR means to be some. Uh, it's been a while, I don't remember. Let me check. OVR. Set logistic regression. Oh yeah. Oh yeah, one versus rest.
Oh,
Okay. So the
okay.
one I was saying, right? So it is
Uh,
yeah. So the one versus rest. That means you are consider this as one, and all the rest will be
yes.
other set.
Other. Yeah.
Okay. So like that we'll see. Okay. So when I think when we are discussing about the next algorithm, okay, which will be SVM, so there we'll also see multi-class classifications, okay, or I think, yeah, here in the classification matrix when we are discussing, right? So over here, we'll see a multi-class example, okay? So for example, you remember this iris dataset where we
Yes.
have flower divided into
Yes.
three
Yes.
categories,
Yes. Yes.
Setosa, versicolor,
That
virginic.
was the. Yes.
This is a multi-class. This is not a binary class, right? Three classes.
Correct. Correct.
Right.
Correct.
So like this also you'll consider whether first thing is you'll say whether the flower is setosa or not.
Correct.
Okay, so setosa 1 and 0. 1 is setosa, 0 is not setosa.
Yes.
So not setosa means it could be these two.
True.
Correct? So 1 versus rest OVR.
Got
Okay, then again you will do separate for this. Okay, that we'll see. Fine. So that is one thing. So basically, if someone asks you that, hey, is logistic regression works only for binary, you can say it mainly predominantly works for binary, but it's not limited over there. We can also make it work for multi-class classification also.
it.
Okay. Then it will expect the data should be linearly separable. Okay. If
Yeah.
perfectly, but at least there should be some linear. If it is completely like this, you cannot separate. Okay, at least it should be some data should be here. So there could be some here and there values can interchange, but at least it should be have a linear separable data. Okay, and usually there should not be any outliers. Okay, that means what? For example, you are having a some data over here. Okay, and some other data over here. Okay, now you are trying to find out a line, logistic regression find. Okay, line, it will try to give you the line. Okay, this is
Yeah.
fine, but if you unnecessarily have some outlier, okay, it will try to take
True.
consideration of this point also. Again, it will try to adjust itself.
Correct.
Correct? It will still it can do the perfect classification. Okay, but unnecessarily it is taking this into consideration. Okay,
Yes.
and the importance for these points might get diluted.
Correct.
Correct. So if it is not there, it will be more perfect line.
Yes.
Correct. So that's why we make sure that we don't have outliers. Okay, so I would say that point, these are the other point. Fine. So yeah, so apart from this, I would say uh, there are no main assumptions. Fine. So that's why whenever you are building a model, right? So you can basically check whether the data is linearly separable, and if firstly whether it is binary classification or not. Okay, then if you are able to linearly separable, you can plot the data and see if it is linearly separable, and then check for outliers in the data pre-processing step. Once your data is clean, then building a model should be very, very easy.
Yeah.
Okay. And hyperparameters also we have seen. Yeah, fine. And once we have the model, right? So for example, you got the model. That model will have few attributes. Okay.
Yeah.
These are the parameters.
Yes. Correct.
Parameter means what? Before building the model, what all values
True. True.
you want to give
Using
that are the
parameters,
parameters.
we can, yes.
But
Yes.
once you build the model is ready, then what
Mm-hmm.
are the things you can get from the model? So those are these. For example, let's say I have built this model. My model is what? CLF1.
Yeah.
Now using the CLF1, I can extract few details. I can check few details. For example, let's say, see here. Here it is saying if I say classes, CLF classes underscore. Okay. So just make note for attributes, we will add a small underscore at the end for all the attributes.
Okay. Okay. Got it.
Okay.
Intercept
So
coefficient.
yeah, so when I'm saying CLF, my model dot classes, so it is saying this is saying, hey, this model, whatever this is CLF1 class,
Only
that is
zero and
trained
one
on
of the classes.
2 and 1 classes.
Got it. Got it.
Okay. And now when I
Oh,
say uh, simply you can you can just say CLF dot, and if you enter tab and wait a
CLF
second,
one data. CLF one
just one dot, and if you enter uh,
tab.
tab,
CLF one dot. CLF
oh sorry,
one.
CLF
Yeah.
one dot. Yeah. So these are all its attributes. Okay, not
Okay.
attributes. You'll get attributes and also
Both
both. Yeah,
attributes as well as the control.
methods as some other yeah, solver, etc., etc. See, by default it is saying it is taking LBFGS. Okay, I did not give anything. For
Yeah.
example, see, I did not give anything. I just gave this. But by default, what is the solver it is using? Where is the solver? By default, solver is LBFGS. Correct?
Correct.
So
Yeah.
that if you don't know what it is using, you can just use this way. Okay.
Yeah.
And second thing is, yeah. So when you do CLF dot coefficient, okay.
Hmm.
So now finally you got line, right? S-
Yeah.
The line. So, but what is line? I told you, right? So the line will be
For each and every feature, we have one coefficient. Yeah.
right, W1 X1 like that. So here also if you sorry, so here also if you see, so you got these are the coefficients. Okay.
Correct.
For example, if you see how many values I
Okay.
have,
How many features we have taken?
4, 5, 6,
3,
7,
3,
8, 9,
16,
10,
9, 12. 12.
12.
Yeah, 12 features. Right?
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
14. Yeah.
1, 2, 3, 12, 13. We are having only 13. Here
I
14.
mean, we have included target too. Yeah.
Okay. Yeah. We'll have only for
Mm.
the input features, right?
Yes, yes.
Yeah, these are the input features. Fine. So these
Correct.
are 13.
Mm.
Correct. 13 for
Correct.
each every feature. For age, what is for 6, what is for CP, what is for TAL, what is okay.
Correct.
So these are the features.
Correct.
Okay. So I would like to just put it here. So it will be so if I just do a dot iloc of some 0, and if I do yeah.
Into 13.
Okay. So this age is related to this. Okay, so this is 1.2 into e to the power of 0 minus 0. That means if you do
Mm-hmm.
1 by 1000, it will be 0.00012 something. Okay,
Yeah.
and this is for 6. This is for CP like that. Okay,
Correct.
and this is for this. So my final line is what? Let's say this is W1, like 1.2
Correct.
something. Okay, let's say I'm saying 0.0012 into age.
X. Yeah.
This is X1. Okay. Our general format. Okay. Now it will be
Mm-hmm.
minus 1.45 minus 1.45 something e to the power of 0 into 6 plus
Correct.
8.16, not 8.16, it will be e to the power of 0.816
Correct.
into CP. Okay, like that. Finally, minus 7.9 means minus 0.79 into TAL.
Yeah.
Okay, this is the
Final line.
line. Okay, so in this, if you put the x1, x2, x3, you are going to get those values. I mean, obviously you got the line. Okay,
Mm.
so how much each parameter is important is getting defined by this. That means age is
Correct.
important
Correct.
by this much, sex is important by
Yeah.
this much. Okay,
Yeah.
w1 x1, w2 plus w2 x2, same thing. So these w's, all w's, right? So this set of w1, w2 till w14, those are fixed
Solutions.
values. Okay,
Yeah.
and plus you will have intercept also, right? B w0.
Mm-hmm.
So that is this CLF dot intercept is this.
Yes.
Okay, this is coefficient, this is intercept.
Yeah.
Okay, so how it got, so it passed each and every value. Okay, so initially it started with some random value of w, and finally these are the final values from the gradient
Correct.
descent.
Yeah.
Okay, so initially when it is experimenting with random values, so it is taking those random value of w1 and taking these x1, x2. So these are for this particular row, this will be the x1. So that random value, these are final values. Okay, don't get
Correct.
confused.
It is starting with a
Initially,
random line.
let's say it started with some random 0, 1, 2, 3. Those values it is putting over here into this 70
Because, yeah.
plus w2 some random value into 1. Like that, finally some w14 random value into 2.
Yeah.
That is wi xi.
Correct.
Agree?
Yes.
That wxi went where? That wxi went into this.
Sigma.
That went into sigmoid. That gave loss. That gave this equation. That w changed. Like
Yeah.
as per your stochastic or batch or mini batch.
Yeah.
How many data points you want to consider,
Correct.
right? Once you do that, then you got new w. With that new
Mm-hmm.
w,
It
again,
goes with another data point.
yeah, again this w will be new. Again this w2, new w2, new w14, new, and again same values like that. For all, this will happen for using the training data set. So all the
Yeah.
training data, whatever you are getting, right? So like that, it is constantly changing these values using and calculating the loss using gradient descent, etc. Finally, it is saying, okay, these are the final values. So now the equation of the line will be this.
Yeah.
Okay. So now the same thing will happen. Now what it will do? Simple. So now this is the line.
Mm.
Okay. Now since this is the line, training is done, everything is done. Now W values are fixed. Agree? There is
Correct.
no more changing
Correct.
of W values.
Correct.
Now what will happen? How it is doing prediction? No, prediction is simple. So when I'm saying this is the line and all the gradient descent, everything, whatever you have done, right? So all this is done. Perfect.
Yes.
Okay. And the training is closed. We are model until it is good, the model is good, fine. Now, when we are doing prediction, see, when I'm doing this, when I did
Mm.
this wipe rate, what happened? That means for this particular row, it is saying answer is zero. How it is saying
Mm.
zero? It is
By
just taking this
substituting,
value,
yes,
correct? So it is
like
taking the first value of this.
71, it will substitute over there x1,
Correct.
x2, x3. I mean,
Correct. It will
age.
put in the place of age 70. It will replace all these values in these features. You will get a some value. Okay, some
Yes,
value. I will call it as some that is WXI.
yeah, correct. That will go
WXI
to sigma beta function.
plus B. Wait. Plus
Yeah,
B. That
yeah,
is also important. Don't, you should not
correct.
forget it. Okay.
Yes,
So you'll also use the
interceptor. Yes,
intercept value. It will add this value. Okay. And that value, it is going to pass to sigmoid.
sigma function.
Okay. So whatever the
Mm.
value you are getting, if it is greater than 0.5 by default, I am saying go to 1. If it is less than 0.5, is greater than or equal to 1, less than 0.5, I am saying, hey, it is 0.
0. Yeah,
Okay. Now it will do this much. Now it will not again try to change the W's. All that is done because that is training
right,
phase done. Now
correct.
when we have the value fixed and we got the line equation, it will just substitute the values, get the value, and just put it into 1 or 0 based upon the threshold.
Got it.
Okay, the same thing that it happened for all this. So when I simply said one step, when I said CLF.predict of X test, whatever the values you are having in X test, how many values, whatever, like 205 values, each and every row it has sent into it, replaced into this equation, gave the value, gave the threshold, check this value and put into one or zero. So that's how you are getting here 1 or 0, 1 or 0.
Yeah,
Okay,
yeah,
clear? Any doubt?
yeah. No, no.
Okay, yeah. So that's how you are getting, and once you get this, you are using this and the actual value to get the accuracy.
Yes, got it.
Okay, fine. So that is the attributes you are having. Okay, and yeah, and you have all other attributes also. You can just play with that. For
Yes, yes,
example,
got it.
in features dot in, it
Number of
will give you how
features.
many
Yes,
features?
30
13
features. Yes,
features. That means you will all have 13 coefficients. Okay, so like that you are having like n features, features in iterations, etc., etc. These are the different features. Okay. Yeah, so I would say this is how logistic regression can be simply built. Okay, and this is just
okay.
one more example, Karthik. Okay, I'll just guide you. For example, you have load diabetes datasets. Okay,
Mm-hmm.
so over here I'm just loading, and here you have two things. One is it is in the sklearn itself. You have, for example, from sklearn dot datasets. sklearn will also provide with few sample datasets. Okay,
Okay, okay, got it.
okay,
Yeah,
so one of them is low diabetes. So here also I'm saying diabetes, there you have diabetes data, diabetes target. Okay.
okay,
For example, if I run this, so if you just see X, so uh, this is one row.
got it.
Okay. So this is one row. For example, if I see the length, this is processed data set. Okay. We'll not understand what are these values, but that is related to some health related data. Okay.
Yeah,
We'll process.
yeah.
Okay. So it is having 10 rows. Okay. This
10
is one
features.
row.
Yeah, yeah.
And this is a this and like that, we're having 442 rows.
40. Yeah,
442 rows and each 10 features.
yes,
Okay. And each feature is, as I showed you, this. Okay. These are
correct,
this might be, let's say, sugar, BP, etc.
correct, correct.
Okay. And coming to target is Y. So if you see the Y, these are the Y.
Yeah,
This is just a number. That means what is probability of getting diabetes or not? Sugar level
okay,
may be something. Okay. So now if you see here, this is not a, this looks like not a binary class.
correct.
Correct. So our binary class would be 0 or 1, right?
Yes,
So you
yes.
got these. So
Okay.
for this purpose, what we have done is, if you see, we have calculated the mean. Okay. For this Y. So what we have done is, it is, yeah. So we are saying we are taking the mean of this data set.
Mm-hmm.
Okay, and wherever the value that is greater than sorry, not mean, median. Okay,
Medium.
and that means 50% of the value. Okay,
Yeah,
out of all the values, we are considering the 50 percentage of the value, and wherever the y is greater than that value. For
mm-hmm.
example, see, you are having all these values, right?
Correct.
See, if you order them,
Yeah,
if you order
yeah,
them,
mid.
see, this is
Correct, correct.
fine. Okay, right from 6 to 53, you are having. right from
Mm.
53, 65. If you order them, finally you are having some 246, some 300. Okay.
Correct.
So mean is perfectly average. Okay. And mode is the highest value, and median is the 50 percentage, whatever the range you are having, right? So in that, the 50 percentage. Okay. Some value, for example, let's say 150. Okay.
Yeah.
So now I'm saying wherever the value is greater than 150, give as 1.
That is correct.
Less than 150, 0. That means all these will be converted into ones and zeros.
Correct.
Correct? Simple.
Correct.
That's how we have converted this into binary classification. And then again, same thing. So train test split. Here we are scaling the data set. Okay, because the X values are different, right? So to bring into some scale, we are scaling the data set. And then building the logistic regression. Simple model.fit, model is fit, and prediction accuracy done. Okay, you got 73% accuracy. Correct. So again, here you can see all the parameters, etc., etc., etc. Fine. So as I said, see, as I said in the two examples, building model is same, building accuracy is same. One single step. What changed here? One more pre-processing came into picture, like to convert Y into categorical. Sorry.
Correct. Binary.
Here you directly have it. Okay.
True.
Like that, once you start working in real industry data set, then there will be different kinds of data pre-processing that you need. For that, pandas is very important. Okay. So that is
Correct.
pandas. Okay. Not related to model. Fine. So once you have this, yeah, you got the accuracy, and then this are few other things we'll see in next class. Okay. But I would say, yeah, so this is how you can just build and check the code of logistic regression. Clear? Any doubts, Karthik?
No, no, no. Okay.
No? Fine. So with that, I think I would say we completed the theory. We saw the code, few hyperparameters we have seen, assumption we've seen. So that concludes logistic regression. Okay. So if you have any doubts, you can say. But I think we covered it almost what all needs to be covered. Fine.
Yeah.
Yeah. And coming to next class, we are going to discuss one of the very important, actually very important class, and very interesting class, that's called classification metrics, right? As I'm telling you, just like how we have regression metrics like R,
Regression metrics. Yeah.
we also have classification metrics, and this is very important because one line is you have built the model, but how well your model is performing, how bad your model is performing. Okay, because in real life you will not build only one model. So, okay, on the data set directly you will not know which is best. You will not know whether logistic is best or SVM is best or which some other.
Correct.
So obviously, you build three, four models. But
Yeah.
once you build three, four models, like then you need to do like detailed analysis, like where logistic regression is working well and where it is failing. Then why it is failing, which area it is failing. If it then what about that some other SVM where it is failing, exact area, okay, and what is its different metrics, okay. To understand that, right? So classification metrics is the one very important and very interesting. You'll enjoy this, okay. Actually, you will have so much fun when you are studying this one. This is very interesting. Okay, so this will be our next class, and yeah, we'll meet tomorrow.
Sure.
Okay.
Yeah.
Any doubts?
No, fine.
Oh, fine. Thanks.
Yeah.
Bye.
Thank you.